Good morning, PCIS pre-algebra students. I hope you're doing well today. I want to congratulate you for finishing Unit 9. We are done with all the new content, and today we are going to spend some time putting together a formula sheet with all the geometric formulas we've learned. And I think this will really help you guys on the quiz. And don't worry, because the quiz is not going to be until next week, and we'll look at how we're going to be taking our first quiz online from home, and I'll explain that more to you guys soon. But for now, today, I want us to put together a formula sheet, and I'll also be sending you a review for the quiz, just going back over all the different concepts that we learned, because there were a lot of different things that we covered in this chapter. So I want to make sure that you guys understood the homework assignments, and that we talk about any questions that you have and go over anything that you may still want to spend some time on, and just really make sure we're prepared for our upcoming quiz. And I don't want you guys to worry about it, so we have plenty of time to get ready and to just make sure that we understand everything. So please feel free to let me know any questions you have. We'll be going over the review sheet together next time, and just really preparing, and so that everyone will feel ready when the time comes. So anyway, I'm going to switch to a different view now so we can start putting together our formulas, and I'm going to write them down on my screen. But what I would suggest is that you guys get like a piece of paper and just kind of organize them all there, or just in your notes is fine too, since you're going to be doing this from home, and you can use your notebook or a piece of paper, or whatever you find that is best for you. So let's get started. All right, so let's begin with some of the most basic formulas that you guys knew even way before you began our algebra class this year. How about a rectangle? So let's say, what I would like to do, or what if I were you for your formula sheet, I suggest drawing a little example of each shape and organizing the formulas next to it. And I know some of you don't like drawing shapes, but it's kind of fun, and it's a nice way to see all of them together and to be able to find the one you need quickly when you're taking the quiz. So I'm going to draw a little rectangle. Okay, right. So you guys know, first of all, we talked about the perimeter of a rectangle. And sometimes I do like P and then a little sub word rectangle, or rec. Or I would draw a little tiny rectangle next to the P whenever I do this. It's up to you how you want to do it. But remember that the perimeter is just adding up each side, right? This side, the left, plus the bottom, plus the right, plus the top. So a lot of times we call that length times 2 plus width times 2. Does that make sense? So we can say like 2 times the length plus 2 times the width. And actually, I know that you guys know this, but you may need this for some of the types of problems where you have to solve something. Let's say it says the length of a rectangle is 5 inches more than the width. The perimeter is blah, 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 and solve for the length and the width. Do you guys remember how to do that? You would write a formula in terms of one variable to solve for both of them. We can go back over something like that later. Okay, and then we also know that the area of a rectangle is length times width, right? So that's really simple. What if you had a square? So what's the difference between a rectangle and a square? A square has lengths that are all for the same side, right? 4 equal sides. So in this case, the perimeter could be 4 times the side. You know that I don't like to use S's for variables usually, but in geometry they tend to use it a lot with squares and cubes. And then the area would be what? Length times width, but in this case, we could say side squared. Does that make sense? Okay, so the next shape I want to talk about is a triangle. Triangles have 3 sides, right? Sometimes we have right triangles, which means we have a 90-degree angle. Sometimes we have an isosceles or an equilateral triangle. Isosceles would be two lengths that are the same with one that's different, or an equilateral, as you guys know, is all three sides of the triangle are equal length. Okay, so regardless of the type of triangle that we have, you guys know that to find the perimeter of a triangle, what do? You really just find the sum of all three sides. I don't think we need to keep writing down a lot of the perimeter formulas because I think that you guys know this. So let's just go with area from here on out. So how do you find the area of a triangle? 1/2 base times height, right? Whenever the height is like, if you took a 90-degree like dotted line, either whether it's a triangle that already has one of the sides is showing you the height, or in this case, you can just usually see it marked on the triangle, height. Okay, and then the base would be the length of the bottom. Okay, so a lot of times whenever students take this quiz, they totally forget about this very important 1/2. Okay, so you must multiply by 1/2 or divide by 2, right? Because otherwise, you're just doing this formula. You're just doing the rectangle. But for a triangle, you know, it's half. So do not forget this half, okay? Next shape is a trapezoid. Remember that sometimes we said a trapezoid looks like a triangle whose head got cut off? So the only difference really here is like you're finding a formula that's similar to a triangle, but you have two different bases. We sometimes call them big B and little b. So here's our little b and our big B, okay? Also there's a height, just like in a triangle, right? And remember that a trapezoid has two sides that are parallel, but different lengths, and then two sides that are not parallel. And sometimes they are different lengths, but a lot of times they're the same length. It just depends on your trapezoid. So this says H here, and you get a different marker. So you guys remember that the area of a trapezoid is 1/2 big B plus little b times the height. So you take your two bases, you add them together, you multiply them by the height and divide by 2, or multiply by 1/2 to the sum of the two bases and multiply by the height, and you get your area of your trapezoid. Who remembers how we should be labeling these units? If this is in, let's say, inches, then I have to make sure that my final answer says inches squared, right? Because if it's area, we're talking about square units. Okay, so next in our chapter, we talked about circles. Circles have special formulas using a certain character, a symbol, or a type of special number that we learned about called pi, right? If you guys remember that pi is approximately 3.14, we know that it continues forever, but it's approximately 3.14. So in the quiz, you can either use 3.14 or you can use the button on your calculator, because you are allowed to use a calculator. And remember that sometimes your answers will be approximate. But to get our formulas for circles, remember, first of all, you know, we've been talking a bit about perimeter, but what do you call the perimeter of a circle? You guys remember that it's called circumference? So circumference of a circle is 2 pi r. That means 2 times pi times the radius. Now, remember that the radius is the distance from the center of the circle to the outside. Remember? And the whole thing we call the diameter. So sometimes they may give you the diameter, and you could just do diameter times pi, because 2 times the radius is the diameter. And some people will remember to do that, but be very careful if they give you the diameter to not just plug in the diameter for the radius, because you'll get you'll get 2 times the answer. So be careful. If you want to use the radius, divide the diameter in half, or use the diameter just multiplying it by pi. But be careful because remember that area is a similar but very different formula. And again, we're going to be going into units squared. So the formula for area is pi r squared. So in this case, you have to be super careful about your diameter. If they only give you the diameter, you must divide it in half and square that number, right? So you take whatever this is, let's say the radius is 6. I would plug it in here. It would be 36 times 3.14 units squared. Does that make sense? So whatever the radius is, you square it. So you multiply it by itself, and you multiply that by pi. So after we talked about two-dimensional shapes, meaning 2 dimensions means like on a flat surface, right? Literally 2 dimensions, length and width, for example. We got into 3D shapes or 3-dimensional shapes, length times width times height. That was the first shape we talked about, was rectangular prisms or rectangular solids. So on your formula sheet, you guys, I wasn't doing this a minute ago, but I think it's a good idea to also label your shapes like triangle, square, circle, you know? And especially as we move forward into the 3D shapes, just so you can keep everything sorted, just in case they tell you cone, and you wanna make sure that you're using a cone and not a pyramid. So, you know, write down the names of the shapes to help you keep yourself organized as well. So here I've drawn a rectangular solid. So this is basically like a rectangle and then blown up into a 3D shape. So as you guys remember, there are 3 dimensions here. So now we have length, width, and height. So remember that you can put these in different places if you want to, as long as you just keep them clear. So we're going to be talking about what is it whenever you talk about the capacity of how much you could fill up the shape, actually. Think about filling it up with little cubes. Okay, let's say this is centimeters. I could fill this up with little cubed centimeters and see how many fit inside, and that would give me the volume. So we're doing volume now. So for a rectangular solid, the volume is length times width times height, right? And then, of course, like I said, with centimeters, if we solve this and our answer was in centimeters, it would be centimeters cubed. So please, please, please be really careful with your units. I don't want you to get confused on the quiz or just in general. Make sure you understand your units. So the volume of a rectangular solid is length times width times height. And one other really special piece of information we learned in this unit was surface area. So the surface area has to do with taking each side, as you'll remember, and adding it up. Let's say I wanted to cut this apart and use it for an art project. What would be the area of each piece that I cut apart? So the surface area of a rectangular solid, do you guys remember? We said like the area of the front plus the area of the back plus the area of the top plus the area of the bottom plus the area of the left side plus the area of the right side. That's a lot to write down. And so what was the shorter way? It's still kind of long. The shorter way we wrote this was 2 times, and remember you can write these in different orders as long as you make sure they're all there. Like 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width. So 2 times length times width plus 2 times length times height plus 2 times height times width. Okay, so when you write your formula out, double check that you didn't accidentally repeat any of these combinations. So we have to make sure we get each separate side. Okay, so remember that once you calculate this for your shape, when you have your answer, even though it's a 3D shape, because we're only talking about area, like the flat area on the top and the sides added together, then it's going to be in your units are going to be squared, just like area was before. Okay. So what would be the difference now? Remember how sometimes when we talk about cubes, it's similar, but there's like a faster way to do it. And I think you guys might remember that I did that video in the green room at school about the volume and surface area of a cube. So if you have any questions, you can go back and watch that video if you want to, or if you just want to see more of me, you can watch that video again to get a little review of this as well. So for a cube, remember that if we want to talk about length times width times height, a cube is like a square, but 3D. Think about your Rubik's Cube. It's the same on every side. Or like when you play a game and you have dice, they have 6 sides that are equal. And so you can actually call them sides. And again, carefully draw it like an S and not a 5, because you know how Miss Cece feels about that. So, of course, that looks like a very ugly S. So I have side, side, and side, because they're all equal. So what can I do with the volume of a cube? If I want to, I can say side cubed, as long as you know that it's actually a cube. And remember, I want you to write the names. Yours is going to be prettier than mine because of the way that I'm writing on this screen. I can't really keep it as neat as I would like, but so we have side cubed, or if you wanted to, you could do length times width times height, but that would be the same as the side cubed. And then how do we do the surface area? Who remembers? So the surface area, it's kind of, well, basically we did it like this, and then we simplified it, and we realized that you can do 6 times the side squared. So let's think about that. 6 times the side squared. So it means that we're taking this side, let's say this, and squaring it, right? Because that's the area of like the front. But how many sides are like this? There are exactly 6 equal sides. So I can just say 6 times this side, this piece. And that'll give me the surface area of all the different sides. Does that make sense, guys? Remember that you can definitely write me messages with any questions, or if I forget something or make a mistake, please write me so I can go back over it or send out a message to everybody again. Okay, so moving right along, let's go to the next shapes that we talked about. I think that the next logical shape is a cylinder. So cylinder, remember, is like, you guys did your awesome projects. A lot of you found really cool cylinders in your house, cans and bottles of things, all kinds of stuff. And you calculated the surface area and volume, which was awesome. So remember that it's still, we have a base that's a circle. So the circle is going to be important here. And then we have this tall section, like a glass or a pan of something. And then we have another circle on the top, and those circles are parallel and they're equal. And so if we want to do the volume, it's so let's say cylinder here. Remember to write your names of your shapes. So the volume of a cylinder is, it's like you take the area of the base, right? So the area of a cylinder would be pi r squared, right? But then we want to multiply it by the height. So we're going to also have this height in here. So times h. So the volume of a cylinder is pi r squared times height, right? And we'll see that repeatedly with our shapes here if we want to find any kind of tubular shapes. The rectangular solid, it was like the area of the base times the height. The triangular prism, we'll look at that on our review sheet. You just take the area of the triangle and multiply by the height. Now, whenever we have some shapes that aren't like a long tube with 2 equal top and bottom, the formulas are going to be a little bit different, like a pyramid or a cone. Those are like a piece of these shapes. So usually they're like a third of it or some kind of fraction that you're going to multiply in front. But if you guys recall, we also found the surface area of this. And I think you might remember we talked about cutting it apart. So if I cut this up, it would be this circle, and then I would unwrap the middle part to make a rectangle, right? And so with that in mind, the surface area of a cylinder is 2 times pi r squared. So think about how pi r squared is the area of one of the circles. So we're multiplying it by 2 because we have 2 circles, okay? Plus 2 pi r times the height. Now this part is kind of weird, but the 2 pi r times the height has to do with this rectangle part that you're going to cut off. And that is because we have 2 pi r, that is the circumference of the circle. So this part here is 2 pi r, and so that ends up being the top of the rectangle, right? So then we have like the length times the width, or the height in this case. Does that make sense? So this is the 2 pi r times the height. Okay? So the other shape that we talked about that has to do with circles was a cone. Do you guys remember a cone? So a cone is like a section of a cylinder. It could even probably fit in it if you had the right size. So the volume of a cone, like an ice cream cone, it is going to be 1/3 pi r squared times the height. So look at how this pi r squared times height is the same as the cylinder's volume, but in this case we're dividing it by 3 because 3 cones could fit inside one cylinder of the same type of dimensions. Okay? Think about how we're missing these pieces, you know? All right. In the chapter, they don't go over the surface area of a cone, but I'm gonna give it to you just in case, because we can double check, but I feel like there was a quiz question that kind of asked you to find this, and so just to be on the safe side, let's go over it. Pi r squared, right? So think about what's that? That's the base. Plus, now this gets kind of funky. Bear with me. Pi r. Now there's even a more complicated version of this, but this is the one we're gonna stick with. Okay, so you'll notice here, I have pi times r. If you can read this, I hope. Maybe I'll see if a marker I have is better. Pi times r times, now this is a square root, okay? So inside this square root symbol, you're gonna have r squared plus the height squared, okay? And so we could try practicing plugging numbers into this later, but so you'll have pi r squared, so you'll have pi and then whatever your radius is, right? And you'll have your height, okay? Does that make sense, guys? All right, so we can practice one of these later, maybe on the review, but let's say that we had here pi times the radius squared, right? Again, that's the base. So let's say our radius is, 3, okay? So let's say pi times 3 squared, 9, right? Plus, so I would say let's do this part first. So let's say our radius, again, is 3, so 9, and let's say our height is 4. So 9 plus 16, that's 25, right? So that works out well. So if we have 25 in here, square root of that is 5. So then we end up with like 5 times pi times the radius, which we said was 3. So you would just multiply all this, add this to whatever this was, and that would be your surface area. Again, remember, units squared. You may get unlucky and have a question about this on your quiz. A lot of people will not, but I want to make sure that you guys understand that there is a formula, and this is it for solving the surface area of a cone. The next shape that we discussed during my previous video was a sphere. It's kind of difficult to draw, but it's like a ball, right? So we still are working with radii here, or radius. This would be our radius. All right, guys, I definitely just had a moment when I thought my phone had died, so that was worrisome, but don't worry, we got it. So moving on here, the next shape we discussed was a sphere. Remember that a sphere is a ball, okay, or a globe. And we still need to talk about radii, or a radius here, because it's kind of like a circle that's become 3D. So we talked about the volume. It's kind of a strange version of what we've been looking at with other circles and other type of round shapes. But we did 4/3 times pi r cubed. Kind of a strange one, just something you'll need to write down for your sphere. So volume of a sphere is 4/3, or 4/3, multiplied by pi times the radius cubed. And again, units cubed, because anytime you have volume, you want to make sure your units are cubed. And then the surface area is 4 pi r squared. Pretty simple, actually. Okay, so from there, some of you guys did, for your projects, some different types of shapes. I really loved it a lot, actually. And a few of you used a pyramid. And I think I warned you guys that you might have to do the surface area of a pyramid on your own. And we can talk about that now. But there's also a formula that we need to learn for the volume of a pyramid. And again, it's something you could probably figure out, maybe, but I want to make sure we're prepared here. So, okay guys, so one more shape that they are going to show you on your quiz is a pyramid. They call it a square base pyramid. So imagine that you have this square on the bottom, right? And then you have these sides, like, I don't know, yes, something like this, right? So you have a vertex, but instead of like a cone, it's not round on the edges. We have a triangle here, you have a triangle here, you have a triangle in the back, and then you have another little triangle on the side that you can't see. Okay, so the volume is not so bad. It's like if you were going to do a rectangular prism, because think about how it has this, well, this one has a square base, but imagine a square, you know, like the back of a truck, like a long rectangular solid. Okay, so remember that that is like length times width times height. But in this case, we are going to do the length times the width, like the area of the base times the height. But just like the cone inside a cylinder, this is like a piece of this, right? Pyramid is like if I cut out a piece. So it's actually 1/3 times the length times the width times the height. That's the volume of a pyramid. Okay, now the surface area is a little bit interesting, and really I would love for you guys to have the challenge of figuring out how to solve it. But since we can't do this in person, I want to really go over it to make sure you feel comfortable if you see this question. So think about how it is a square pyramid. So the base is a square, I mean. And let's say that you like took apart the top and spread it out. You would have like a triangle here, 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 and here, right? And they'd all be equal. Does that kind of make sense? So how do you think we find the surface area? Well, first of all, we have to add this base in. Remember, the surface area is just like if we're gonna paint all the sides. So the surface area would start with the area of the base. So let's say, what do you want to call it? We can either call it big B or maybe length times width. Right, so basically the area of the square, say area of the base, okay, plus we have to multiply, we have to find the area of one of these triangles and multiply it by 4. Does that make sense? So let's say, so they have to give you actually one more measurement with these, and you'll see it on your review sheet, but because the height of this thing is down the center, and that doesn't really help tell you about the sides. You have these side triangles that are angled. And just like we talked about, if you wanted to know your height, I'm not gonna take the tape measure and do it sideways, right? We talk about straight up and down. But these triangles are sideways. So in order to get their correct height, I would have to put the tape measure on a slant. And they actually call this the slant height, okay? So the slant height would be a different type of height down the edge of that triangle. Can you guys see that? So this measurement is the slant height. It's different than this height, which is dropped down in the center. So they're going to tell you the slant height or the height of one of these triangles. And so what you have to do is calculate the area of one of these triangles. So it would be, you know, the area of a triangle, 1/2 base times height, okay? And it's not this height again, but it's one of these lengths, right? Here, like one of these numbers, times the slant height that they're going to tell you, divided by 2, okay? And how many of those are there? In this case, there's 1, 2, 3, 4. So you're gonna do 4 times that. Could we simplify this? Surface area is the length times the width of the base, or big B, sometimes they would say, as to signify the area of the base, plus, now this can be simplified a bit. It's up to you guys, but see how you have 4 times 1/2? So on your quiz, if you want, I would go through really methodically and be like, okay, the area of this plus this plus this plus this, that's the 4 triangles, plus the base. Does that make sense? Okay, that's totally a way you can do it. So this is like 1/2 base times height, 1/2 base times height, etc., right, times 4, plus the area of the base. But to shorten it, since you're doing 4 times 1/2, if you think about it, combining 2 of these and 2 of these, you can just do base times height, right? So 4 times 1/2 is 2. So we can say 2 times base times that slant height of that triangle. This is probably the craziest thing that we've had to do recently, ever since you guys learned those formulas for the 3D shapes, which you did great with. But please send me a message if any of this is too weird, and I can go over this pyramid thing again. There's going to be one on your practice review sheet, so don't worry. You're about to get some practice on this. So, I think that's it for your formula sheet. If I forgot any, please send me a message and we'll add it on. If you want to add any other special formulas on, feel free, or you can ask me first if you want to. But sorry that this looks a bit messy. This last one with the pyramid is just a little bit different, and I hope that this was clear. But basically what you do is you just deconstruct the pieces and add them together. So send me a message if you want to go over this again. The surface area would be the length times the width of basically the area of the base, plus 2 times the base times the slant height of one of those triangles, okay? All right, I'll be sending you guys your review sheets, and then next time we'll go over that together, okay? Have a great day. See you.